Okay? Okay, we want to find the relative minimum and maximum here. So here we have a function x cubed minus 3x squared plus 3. So the first thing we need to do is find our derivative, which is 3x squared minus 6x. We set this equal to 0. This will give the critical points. The critical points are always the most important part of our graph. So now we factor out, we choose our greatest common factor, which is 3x. So that would be x minus 2, which is equal to 0. So we have 3x times x minus 2 is equal to 0. Okay? 3x is equal to 0. Therefore, x is equal to 0. Over here we have x minus 2 is equal to 0. Therefore, x is equal to 2. These are our critical points. These are our critical points. These are the most important parts because the shape of our graph is based off of our critical points in this case. All right, so now I'm going to erase it. What I need to do now is set up a timeline. I'm sorry, a number line. So I'm going to leave this here. And recall our critical points were 0 and 2. So we set up a number line. 0 and 2. Now, this is what we do. We can choose any number from negative infinity up into anything below 0. So if you choose negative 1, that's fine. Negative 6, that's fine. Negative 5, that's fine. Negative 25, that's fine. As long as it's in that interval from negative infinity all the way up to 0. Okay? Our next test number that we're going to use has to be between 0 and 2. For instance, we will use 1. That's the obvious number you choose between 0 and 2. Our last test number that we will use will be greater than 2. Anything from 2 to infinity. So you could choose 3, 4, 8, 15, 25, whatever we want. So now, yeah, I'm just going to choose a number like negative 5. Okay? Negative 5, that's my test value. I'm just going to put it in right here. Negative 5. 3 times negative 5 is negative 15. And negative 5 minus 2 would be a negative 7. But a negative and a negative make this a positive. Alright? Now, I don't need the actual numbers. I just need to know is it positive or negative. Now I choose any number between 0 and 2. Let's choose 1. 3 times 1 is 3. 3 times 1 is 3. But 1 minus 2 is negative 1. So a positive 3 times a negative 1, that answer would be negative. So we choose a negative 1 right here. So we'll choose, and I'm just going to put my test value, I'll put in 1. And over here, we could choose any number larger than 2. Let's just choose 3. 3 times 3 is 9, which is positive. 3 minus 2 is 1, which is positive. A positive times a positive also gives us a positive. Okay? And my test value here was a 3. You don't have to put the test values, but just for the sake of the video. Now, this is what this tells me. This is what this tells me. From the interval, it is increasing because of this positive from negative infinity to 0 and also from 2 to infinity. This graph is going to be going up. All right? It is decreasing from 0 to 2. Now, we can use this. Anytime you increase, you're going to reach what? A maximum point. Anytime you decrease, you're going to reach a minimum point. So now, we find a relative maximum at 0. We plug that 0 in, and now we substitute 0 back into the original. 0 cubed is 0. 3 times 0 squared is 0 plus 3. So we have a relative max at 0, 3. We have a relative minimum at 2. Let's plug this in. You can use mental math or scratch paper. For the sake of the space, y'all, we're going to have to do it mentally. 2 cubed is 8 minus 3 times 2 squared. Remember, order of operations. That's going to be important. That's an easy mistake to make. That is 8 minus 12, which is negative 4, and negative 4 plus 3, which is a negative 1. So now we have a relative maximum at 0, 3, and a relative minimum at 2, negative 1. Now, how does that look? I'm going to have to erase this for space. I'm just going to give you I'm going to make a small graph. Okay, 1, 2, 3. Now, we know that this is increasing. Now, we will have to find our x-intercepts. For the sake of this video and the brevity, we won't do it right here, but we will have to find these x-intercepts to be specific. Okay, we'll do that. But for now, we know it's increasing from negative infinity to 0, and the maximum is at 0, 3. We want to find a rough sketch for what we're doing. Like I said, for the brevity of it, we're going to have to find the x-intercepts to see exactly where it crosses. All right. But now, for the sake of this video, we're just going to have it going up to 3. You can use a calculator, a graphing utensil. So it's going to be somewhere in there. All right. And my relative, and this is just going up, and my relative minimum is going to be at 2, negative 1. To negative 1, and then what happens as you get there is going to increase again. I'm going to stress this again. These may not be the exact points. I'm doing this just to show the increasing and the decreasing values. They're going to probably be right in there, but we want to get a sketch of what we're doing. So look, the graph will not lie. It's increasing from negative infinity up to 0. It's decreasing from 0 to 2. And then it's increasing again from 2 to infinity. So that's how we find our relative maximum and minimum. Like I said, so we have a good rough sketch. A graphing calculator, checking it will give you the exact x-intercepts, but everything else is right on the money. And this is good too.